First thing we're going to do in example 4 is put an X through, because we're going to skip this example and do another example instead. And you actually might want to turn to the top of page 144, and you can write out, we're going to do this as our example 4 instead. Solve for X, and we have the square root of X plus 3 is equal to the square root of X minus 5 plus 2. And this is going to introduce something interesting and somewhat problematic for a little bit. Okay, we're going to go with the same steps as always. How do you get rid of a square root? You'd have to isolate it and square root both sides. But we have two square roots. Can you see that the one on the left is isolated, but the one on the right is not? So we're going to do the following. We're going to isolate one of them in square, dot, 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 and then you're going to have to isolate again. And square. So watch what happens. So, okay, I've got one isolated. If I square this, that gets rid of my square root sign. Things I think are going to be good. But then I have to put the whole other side in brackets and square it as well. Well, squaring this side is just going to give me X plus 3. I'm going to put it in brackets just to hold it together. Doesn't need it, but sometimes when you get rid of something, it's nice to put the result in brackets just in case it's important. On the other side, though, the number one mistake is students just square this and just square this. But we have to remember, what does squaring mean? Squaring means you are multiplying by itself. So if I actually rewrite it as multiplying by itself, it's like, uh-oh, I have to multiply all of these things. And if you've never seen a question like this before, at this moment you feel like, I think I did something wrong. This seems more complicated than it should be. The answer is no. You haven't done anything wrong. It is this complicated. What's going to happen is this side is still an X plus 3. Don't need those brackets. I'll take them away. If I multiply it this times this, a square root times a square root. The square root will go away. I'll just have X minus 5. But my outside one, a square root times 2, will be 2 square roots of X minus 5. And the inside one will be another 2 square roots of X minus 5. And finally, 2 times 2 will be plus 4. And although isolating and squaring got rid of the one square root, it seemed to create 2 square roots on the other side. Was it any better? Well, do you see that these 2 square roots are at least like terms? So I'm going to start putting my like terms together. So I'm going to, on this side, I'm going to put 2 plus 2, I'll stick with the color blue. Maybe. It's not like me. Whatever. Those are like terms. 2 root X minus 5 plus 2 root X minus 5 will be 4 root X minus 5. Can you see the X and the X are like terms, but they're on either side of the equation? What would happen if I put them together on the same side? See, your X would cancel out. X is gone. The 4 and the 3 are like terms. So if I move my 4 over, I'm going to get minus 1. Okay? So we isolated 1. I guess 1 should have an E on the end of it. We isolated one of them and squared. And now we have to isolate again and square again. Yes.
So the root x minus 5 is combined because they're like terms.
Yes.
The 4 moves to the other side.
Make it a minus
The
1.
x's
Oh, I
cancel
forgot
out
about the 5, right?
Yeah.
Thank you. The 4 moved to the minus side, minus 1. The 5 would also have to move to the other side. We would get 4. So maybe it would be good that I show I added 5, I added 5, I subtracted 4, I subtracted 4, and I subtracted x and subtracted x. Perfect. So, we technically have the term with the square root isolated. You could either square now, or you could simplify. If you can simplify and not get a fraction, I recommend it. Sometimes, like if it was still a 1, you see that dividing by 4 would get a fraction on this side, then I might square early. But in this case, if I divide both sides by 4, I just get 1. And now my square root is all by itself. It makes sense. Square this side, square this side. 1 squared is 1 equals x minus 5. Add 5 to both sides. And I get x equals 6. But I still have to check my original equation. Does this work? Left side and right side. So, left side originally was the square root of x, which is now 6 plus 3. The right-hand side was the square root of x, which is now 6 minus 5 plus 2. This is the square root of 9. This is the square root of 1 plus 2. Those square roots you can figure out. Square root of 9 is 3. Square root of 1 is 1 plus 2 is 3. Yes? These work, so our answer is correct. So there are times that we have to square both sides more than once. That's when we have a double square root and an extra number, and you have to be careful and remember that you need to FOIL. And they tend to have the double square roots more after chapter 3 and 4. So there's no homework questions to do in there. I can make one for you if you like. Here's one to try. How hard should I make it? Super hard or not super hard? We'll see. We'll see how it works out. I think it should work. So try that one on your own.